author of Xgboost, that famous library and package we have heard about in recent lectures today. And Tianki will tell us more about his development, his initiative called DMLC, and hopefully some insights on how Xgboost actually works and why it succeeds so nicely. So, Tianki, you're welcome to start.
Okay, cool. Yeah, so sorry that I cannot, seems that I cannot do the full screen, so I will directly use the presentation mode here. Okay. So,
Tianki, could you please make a full screen of presentation?
Yeah, let me try. So I think I can do presentation. Can you see the slides now?
No, we can see the slides.
It's not full screen.
Maybe you could just click F5. Okay.
Yeah. So it's not. I guess the screen is not shared. The presentation screen is not shared on your side. So that's why I only shared the other screen. Yeah. So can we do it in? Let's see.
Я тем временем пытаюсь прикинуть, откуда идут колонки. Куда он высасывает.
Can we use? Yeah, I guess I will directly go with this slide. Since can you see the slides clearly?
Yeah, we can see the slides. It's like in just normal PowerPoint interface. So it's not presenting.
Yeah. So I tried presenting, but seems you cannot see the presenting mode. So I guess that there is some problem with the Hangout integrating with the PowerPoint. So okay, so sorry about that. So can we just start with this one, like this mode?
Yep. Okay. No problem.
Yeah. Okay. I guess I will just zoom out the rest of the thing and trying to make the slides part bigger. Okay. Cool. Okay. Thanks Alex for invitation. Today I'm going to talk about mainly about mathematical background about boosted trees and hopefully give some insights on what is Xgboost and why Xgboost is accurate and fast. Okay, cool. So here's the outline of the talk. To begin with, I want to introduce some of the basic principles that we are using to solve all these kind of problems. As you see that there are many problems in data science that can be formalized the problem of supervised learning. So why do we want to talk about this? One of the important thing when we're dealing with problems is we want to formalize them and trying to understand them by decomposing our problem into different components. So in most of supervised learning, we are is asking us to make a prediction based on inputs, where the input X can be some input features like age of the user, the gender of the user, and the property of the house, and we are asked to predict whether some score that represents something of interest. For example, it could be whether the user is rich, whether the user is likely to like the product, what is the predicted price of the stock market, or something like that. And in this kind of supervised learning, important the general problem is that you are taking some input and you want to map it to a score that you're interested in. And there are three basic components of supervised learning. So the first component is called model, whereas in the model it basically tells us, given input, how do you make the predictions of the output. And the second thing is called parameters. This is the thing that we need to learn from the data. And in order to learn these parameters, one of the important things that we always need to define is called objective function. And usually the objective function consists of two parts. The first part is quite intuitive. It means it's called training loss. It measures, like, for example, if you want to fit the data, if you want to predict the price of stock market, and we use the price of stock market today, it's very desirable that our model fits to today's data, so that at least we can predict, given the true answer, at least we can predict this these things accurately. And there's another part called regularization, which is usually ignored by most of the people in the beginning. So this regularization part kind of encourages how effective this. Okay. Hello, can you still hear me? Yes. Seems it's getting stuck. Yeah. Can you still hear me? Only yes.
Можете выключать Wi-Fi и Steelhack 2? Тот, кто подключен на Steelhack 2, может быть, мы просто отжираем канал. Да, окей.
Okay. So okay, can you still hear the presentation?
Yes, right
Yes.
now everything's fine. We just turned off our video.
Oh, screen sharing and present. So I mean, this is very. So hello. Hello, can you still hear me on the? Interesting. Seems only me. Alex has left the group chat. makes me feel stupid.